Welcome, everyone. I hope you've had a good time so far attending all the sessions at Couchbase Connect. So continuing on the track of all things cloud, today we're going to talk about observability in Couchbase Capella. So when we speak about observability in Couchbase Capella, the main focus area is going to be about understanding how to detect and triage failures in your Couchbase cluster, analyzing these root causes, why did a failure occur, for example, and fixing the failure. We want to understand these 3 points from the perspective of how Couchbase Capella helps you do all of this without having to reach out to support, and how it empowers you to do this without even having a lot of contextual knowledge about the Couchbase cluster even. So before we delve into the details of how Couchbase Capella helps you with all of this, let's take a step back. And I really want to help you understand what observability is all about. I think we've always heard this term, observability, when it comes to trying to figure out what's wrong with your internal system. So I think observability helps us understand the first thing, which is why is a particular operation slow and what is slow, for example. And it also helps us understand what is broken in the internal system and why is it broken. We always hear terms such as logging, metrics, and tracing, which we use. And if we have an internal system, we have our applications, they will always emit these 3 things. And these are essentially the signals that help us observe the health of our internal and external systems, right? These are the signals that will help you detect the root cause if there's a failure. These are always referred to as the 3 pillars of observability. And I think in any production system that you have out there, these 3 signals are easily available and at your perusal to be able to understand and detect root causes of failures. But the issue with observability when you have these signals is that you need to actually correlate them at a single point in time. So for example, if you see that a lot of your HTTP requests are failing with an internal server error, you need to use, the first thing you do is you look at logs. And then for the same point in time, you drill deep down and look at the traces that your application has emitted. Metrics are the first level of signals that help you understand that an issue has occurred. Often you will receive an alert on any of your pager systems, which will be based out of these metrics. And that's when later on you drill down to using the logs and traces to triage the issue further. So essentially, observability is reading between the lines. All you need to do is find meaning out of all of these signals that you have out there. It's been made really easy to even capture these signals thanks to all the monitoring tools that are present. But reading between the lines still remains a very manual process. And it often is very tough, I think, for one particular reason, which is that you need to correlate all of these signals. And that also in a very manual way. There's no automated way to do this. In the context of Couchbase cluster, if you were to manage your own Couchbase cluster, you would always have to look at the logs or the metrics that Couchbase cluster provides you with. And then you would need contextual knowledge. You would need to understand the cluster and the services and the internal workings well to even understand the root cause and when did it occur and what actions caused that kind of a failure. And that's why observability is tough. That's where Couchbase Capella comes in. Couchbase Capella provides this observability out of the box for your Couchbase cluster. So if you've deployed a Couchbase cluster in Capella, you will get a bunch of functionalities and features which will make it easy for you to observe and detect and even fix most of these operational issues firsthand by simply using the Capella UI. I hope that by now you've had the opportunity to attend the keynote speech by Scott Anderson, where he mentions the key tenets or the principles that Couchbase Capella is based upon. One of the main tenets is that we want to reduce operational overheads. For example, the deployment time has been reduced drastically, and deploying clusters is easier than ever. And you can have a 3-node cluster spun up in minutes, for example. The deployment of the clusters is secure. It's resilient in the sense that it will always be highly available. If a node restarts, it's going to guarantee that the service is not impacted or down. You will always have a second pair of servers running within your cluster. We also make sure that there's disaster recovery steps. You can back up your data. You can always restore that data, and any data loss does not happen when a node restarts. But that being one side of the coin, the second side is making clusters observable. And that's where Couchbase Capella adds operational intelligence for your Couchbase clusters. You don't need to worry about any operations-related failures at this point, because Couchbase Capella will make sure that you can easily detect operational failures, you can analyze operational failures, also understand the reason why an operational failure occurred. It will also help you understand things such as if a Couchbase service for some reason is not performing well, and the root cause for that is an operational failure, it will help you understand how to avoid such a failure in the future. And it will also provide you actionable alerts so that you can fix these operational failures right there without having to reach out to support or having to depend on any other company or individual. So it empowers you to fix an operational failure without knowing much about the Couchbase cluster. That brings us back to the focus point. That is where we want to detect failures, analyze failures, and fix failures. And that's what Couchbase Capella does for you. At Couchbase Capella, the way we understand the overall health of the cluster is really simple. I think at the bottom of it, we see cloud servers, which are essentially servers or nodes, or physical nodes at the end of the day, which are deployed in your cloud provider. Within these servers, we have Couchbase processes running. So if a cloud server was supposed to go down or restart, that would essentially impact the Couchbase service that was running on it, or the Couchbase bucket that was deployed on that server. A Couchbase bucket could be deployed on a single server or multiple servers. So a restart of a single server is going to impact the availability of the Couchbase bucket. And that will essentially also impact the Couchbase services. We've also gone one step ahead to understand how does the unavailability of the Couchbase service, such as a query service or the index service, impact the data tools that Couchbase Capella provides on the UI. Couchbase Capella provides a bunch of data tools so that you can interact with the Couchbase cluster directly, such as the query workbench, the indexes UI, and we have the documents editor. So for example, if the server on which the index service was running was to go down, it would mean that the index service is now unavailable or impacted, and that could cause an impact on backup and restore, for example, or the query workbench. So that's the hierarchy of impact when it comes to the overall health of the cluster. You can drill down, you can decide the overall health at the cluster level. Is it green? Is it healthy? Is it impacted? Or you can also drill down and understand what is impacting the overall cluster health. For example, is it the service that's the index service? Is it a bucket, which is the travel sample bucket, which is unavailable? And then all the queries for your bucket are going to fail. So that's how the drill down can also be seen easily on the Capella UI. Now let's talk about the first piece of our focus point, that is root cause detection. And we want to understand over here how we can use Couchbase Capella to easily detect or to better detect the operational failures. The first thing, the first step to detecting issues within your cluster is to get alerted on it, right? For example, if you have a bunch of clusters, which are all production clusters and deployed within Couchbase Capella, you need to be notified about an issue that is happening within one of your clusters. The way that Capella does this is by providing notifications on the Couchbase Capella UI. So you will see like a alert banner which states the severity of that alert, and it also tells you the time since the alert has been occurring and the number of times the alert has occurred for the same cluster, which means that there is a way to track the historical occurrence of the same issue within any point in time. You can always go back and see how the issue was resolved when it occurred the first time. Was it auto-resolved? Was it resolved because of some action that was performed by the user? Or does it still persist? The severity is very important. It tells you how critical the alert is. If it's a warning alert, it's probably okay to ignore it or act on it after some more time. And also, it could be something that could auto-resolve. Let's say if you have a production Couchbase cluster that's deployed in Capella, and there's a particular time slot, say 10 a.m. to 11 a.m., when you see a large amounts of data being ingested in your cluster. And that just fills up a lot of storage. And then you get a warning alert during that time that your storage capacity has really increased. But eventually, after 11 a.m., what happens is most of these documents are deleted by whatever application you're using. Then that means that the warning alert will auto-resolve itself because now the storage has gone back to below average capacity. And so that means that maybe it's an interim alert and a warning alert can be ignored if it's an expected alert as per your use case. But if it's a critical alert which has been reoccurring and it hasn't been looked at, that's where you need to act on immediately. And that's where the severity of the alert really helps. You can acknowledge the alert and you can also act on the alert. And we'll go into the details of acting on alerts in the later stages of the presentation. Another important point is subscribing to these alerts. So let's say if you don't have the Couchbase Capella UI open all the time, and you really want to know about these critical alerts, you can always receive notifications via email. And you can always opt in to receive these notifications. Those will be real time, and you can immediately get an email and open your UI and then fix it. So I think that's how Couchbase Capella will help communicate these alerts to you. The next thing that's very crucial if you want to detect root causes is that you want more granular metrics. Earlier in Couchbase Capella, we did not provide metrics which were per node, and we didn't even have things such as drilling down and selecting the time range of viewing the metrics. Now you can see that we can select the metrics for every individual service, such as the data service for Couchbase, and we can also have metrics which are based off per bucket or per node. This helps us understand which data node are we seeing CPU spikes on. Is it just one single data node, or is it across all data nodes? We can also easily see on the right-hand side that we can always select the time range. Is it for the last 30 minutes? Is it for 1 hour? And we can go up to 1 month. We can also use the calendar dropdown and select more than 1 month worth of time range if you want to observe these graphs for a historical reference. So that's the main point, that we have more granular metrics. Okay, so that is how we have granular metrics. The next thing that we want to talk about is how we can drill down into a graph. That means how we can zoom in. Let's say if we detect a spike or an anomaly into one of the graphs and we select that graph from the UI, we can always zoom in to that time range and observe all the other graphs, how they've also zoomed in. And that's how it's easy to zoom in and correlate metrics, such as I can correlate over here the CPU utilization by node with the connections for that node and the memory that's available, again, for the node. That's where the drill downs come into picture. So when we talk about correlating metrics, it's important to know that we are now collecting granular metrics which are not just related to Couchbase services, but are also related to the processes, the threads, and the resources that are running or are consumed for every single server node, which means that we can easily get, we can now easily visualize metrics which are infrastructure related, and we can relate those metrics with the metrics which are related to Couchbase services. For example, we can relate the resource consumption on a data node with the rate of get operations for a bucket, which is also deployed on the same node. So I think that's the main point, to have more granular metrics, to have improved graphs, which are very interactive in nature and help you with the correlation. With the time range option in the Couchbase Capella UI, we can also go back in time and also have a look at the historical metrics that were collected for the same cluster. So in all likelihood, we can answer some questions such as what is causing CPU spikes on node 1? And also try and correlate if those CPU spikes were impacting certain Couchbase services, such as the data service. Why are get operations slower than usual for a particular bucket? So when we say slower than usual, that's where we can go back in time and see that the average rate of get operations was X%, and now it has suddenly dropped down to Y%. And that's where the historical reference comes in really handy. Is the index service, for example, is the index service unavailable? And does that impact some of the Capella features, such as backup and restore? So now that we've seen how Couchbase Capella and the improved features of Couchbase Capella, how they help in detecting root causes, we still see that despite having all of these granular metrics and these improved graphs, we still need to know and have contextual knowledge about the Couchbase cluster. We still need to understand if the infrastructure or the operational issues are impacting the Couchbase services. So we still have to, we're still concerned about the problem with observability, which is having that contextual knowledge. I think Capella, as such, attempts to remove that contextual knowledge by providing customers with a root cause analysis, by providing you with a probable issue, with a probable reason as to why the issue occurred. So let's look at how that is done. So with Couchbase Capella, without even understanding much about the cluster or even having to drill down into the cluster details or how your application is using, how the application is writing data to the Couchbase cluster, without having to do all of that, you can still understand all of these signals, which are the metrics and the events that are occurring and are displayed on the Capella UI. So for example, what we see here is on the left-hand side, we see a particular alert which says that the data service persistent storage has reached 99% of its capacity. And at the bottom, you can see two tabs. One is the details tab. In the details tab, you will see a description which will help understand what will happen? What action should you avoid? For example, if my persistent storage for the data service has reached 99% capacity, if I continue to add more documents, it's going to fill up the cluster. And that is what the description tells, that this is the action that you need to stop performing, or this is how you can fix the issue temporarily. It also tells you that you have to take an action to address this problem. And at the bottom of that screen, you can see the actions that it's suggesting. It's suggesting that you either add more nodes so that you can vertically scale your cluster, or you grow your storage so that on the existing number of nodes that you have, you add more storage and horizontally scale the cluster. You may also see a visual representation of the same graphs that you saw on the cluster dashboard, which are specific to this alert. On the right-hand side, I can also see the second tab, that's the related events tab. Over here, I can see the list of all the events that were a part of the same issue. For example, the first time the persistent storage alert fired, I can see that the first occurrence was on Jan 1. After that, I can see that a particular user or an employee in the Couchbase Capella organization acknowledged that alert. And then I can see that there are a bunch of other events which say that the alert was auto-resolved and then a critical alert was fired, after which an action was taken to grow the disk space. These related events basically provide with an RCA. Basically, it's a timeline that helps in your reporting of the root cause and the issue and why it occurred. That's another thing which will help in understanding the historical reference and also go back and pinpoint the exact time and date when the issue first started occurring. Now going ahead to actionable alerting. We did see the alert banner earlier in the slides, where we saw that we get different types of alerts based on the severity, which also tell us about the criticality of the issue and also tell us about the impact, right? This alert banner also provides you with two actions which are usually operational. So for example, if it's an operational failure, you will have a probable action that you can take. It will suggest a way to resolve that issue firsthand. For example, you can grow the data storage or you can add more data nodes. That is where actionable alerting comes into picture. You don't have to have the contextual knowledge. Capella as such is already suggesting you how to easily fix the issue. And all you need to do is just click the button and decide how much storage do you want to grow, how much disk space do you need to add, how many data nodes do you need to add, and so on. And then you just click the deploy button and Couchbase Capella will scale up or scale down the cluster, whatever action you choose to take. And that's where we are removing the barrier of having, of depending upon the support team or depending upon the external teams to understand how to fix the issue, and also having contextual knowledge of the cluster. So now we're going to deep dive into the architecture, try and understand how Couchbase Capella actually fetches all of these alerts, metrics, and how are these metrics even displayed on the front end when on the Couchbase Capella UI. Let's start by looking at the two main components of the Couchbase Capella architecture. The right-hand side talks about the control plane side of things, the services that are core to Couchbase Capella. And the left-hand side is the data plane, and that represents the cloud architecture where your Couchbase cluster gets deployed. So it's going to be in one of the cloud providers that you choose. So we can see on the right, let's focus now on the left-hand side. We have a single server node, which is essentially just a Linux machine, for example, it will have the Couchbase processes running on it. It will also have two more processes. One is the node agent process, which is responsible for fetching metrics which are specific to the resource consumptions like memory, disk, and CPU. And we have the process agent, which is responsible for fetching metrics related to processes, threads, kernel level processes, and so on. So these are the, I can say that these are the metric emitters or the sources of truth. These are the main components from where we fetch the metrics. We also have another process, which is the data plane agent. The data plane agent has multiple roles and functionalities. The data plane agent has multiple responsibilities. One of the responsibility of the data plane agent is metric collection. So for example, on the Couchbase Capella UI, when you go on the dashboard and you select a metric to be displayed, it displays a graph. So to do that, the metric collection logic gets triggered, which goes and collects metrics from each of the metric emitters, like the process agent, the node agent, and the Couchbase processes. The metric collection always happens in the boundary of a single server. So if you have a 5-node cluster, for example, metrics collection will happen at the cluster. It'll happen at the node level for each of those 5 nodes. The second responsibility of the data plane agent is to aggregate these metrics. So if you have a 5-node cluster, you've collected metrics from 5 of these nodes. Whenever the metrics are supposed to be displayed on the Capella UI, we need to aggregate these metrics before they're sent out from the data plane. So the metrics aggregator happens at the node level, but it will aggregate metrics for all the 5 nodes for the Couchbase cluster. So for example, if for server node 1, the metrics aggregation logic gets executed, server node 1 will aggregate metrics from all the other servers as well as itself, and then it will push out all the metrics. Just cut the push out part. It will aggregate metrics from all the nodes, which are then sent to the control plane. Now, at the control plane side, we use the federated Prometheus architecture. The federated Prometheus architecture means that we will have a main single Prometheus, which scrapes metrics from individual Prometheus. And each individual Prometheus is going to pull metrics from different targets, the target being a data plane. So when on the Couchbase Capella UI, we click to display the graphs, the federated Prometheus instance schedules a scrape of the metrics for your Couchbase cluster. So when it schedules the scrape, that is when the metrics aggregation logic gets executed, and it emits metrics on a particular HTTP endpoint, which is scraped by the federated Prometheus. Later on, all of these federated Prometheus have scraped the metrics, and these metrics are then scraped by the main Prometheus, which is where you have metrics from multiple such Couchbase clusters, and you've received them. So essentially, you have a fleet of Couchbase clusters, each of these acting as targets, and the main Prometheus receives metrics for all of these Couchbase clusters, and it stores them in an open source tool called Thanos, which is used for long-term storage of metrics. And when on the Couchbase Capella UI, we plan to display these metrics, these are displayed directly from this main Prometheus. And that's how you get all of those graphs, and that's how you get all of those alert notifications. because of some way in which another service within the control plane interacts with the main Prometheus. So so we've seen how we can observe our clusters better with the new and improved features and functionalities that Couchbase Capella provides. But that's just one step further that Couchbase Capella has taken. We have a vision, and the vision is proactive monitoring and proactive observability. At this point in time, we would have realized that getting an alert on the Capella UI and clicking a fix button is a very reactive way to fix something. An issue has already occurred, and we are reacting to an issue that exists. The mission of Couchbase Capella is to predict problems before they occur. We want to be able to study the historical trend of the Couchbase cluster that's deployed in Capella. So that's where the baseline predictions will come into picture. It will help you understand what's the baseline and what's the average behavior for your cluster. When a certain operation is performed, it will help understand what is the average behavior for the resources that are consumed on the cluster. For example, if you're adding a bunch of documents and writing millions of documents, we can predict the average number of resources that you will require if you want to perform that operation. And that is when Couchbase Capella can suggest if there's going to be an issue that's going to occur in the future, and if it's not. The second point is insights generation. It will generate insights for the use cases of your cluster. So it will tell you more about how many documents are you writing in a day, and what are your traffic patterns. If there's anomaly that we can detect, is there an anomaly? Is there a spike or a dip? Can we do this using the baseline predictions and not just give you real-time present information and historical, but also generate a graph which is a predictive way to understand if the health of your cluster is going to degrade over time. And the final way is we want to achieve a way where we can self-heal the Couchbase Capella cluster. If we see that the persistent storage is going above 99% of its capacity, can we go ahead and just fix it for you? Can we just rerun the same action that you performed earlier? Or can we ask for your permission to fix it without you having to worry about why the operations are failing for the cluster? So that's where the future of Couchbase Capella lies. So I hope you've gotten some great insights from this presentation. Thanks a lot.